Hey guys, this video is about operations with monomials. It builds on our last two sections. It uses all the same properties. Nothing actually new here, just sort of bigger, slightly more complicated problems. So these first three are ones I would do on the board, and this is just straight up multiplication. So we're just going to go negative 9 times 3, negative 27, and then x to the 4th times x to the 6th. Remember, here's where we're adding our exponents. So that's going to be x to the 10th. If you think about what this really is, it'd be 4x's and 6x's. That makes 10x's altogether. For number 2, this one's going to be a simplify, kind of like just simplifying a fraction. So for 45 and 18, I kind of see they have a 9 in common. So 9's going to go into 45 5 times, and it's going to go into 18 twice. So that's going to leave me a negative 5 halves. And then here I have 5x's up and 3 down. You can think of it as a subtraction and get x to the second, or you can think of it as canceling and just think 5x's up, 3 down, so it look like this. I'm not saying you should write all that out, but this is kind of what I'm thinking in my head, and then that leaves the x squared up top. For this one, we could multiply those or do the 3 first, either way. I think I'll write it as 60, and then I have 6 and 9, so it's going to give me 15 if I kind of group those together. And on the bottom, I got 3x to the 20th. So 3 goes into 60 20 times, and the 60 is up top, so that means the big number is where the leftover is going to be. So 3 into 60 20 times, with the 20 up top. And I have 15x's up, 20 down, so if I subtract, I would get x to the negative 5 if I go 15 minus 20. So that tells me it belongs in the denominator. Or just think of it as canceling, and if you canceled out 15x's, you'd still have 5 left down here. Okay, these are the matched problems I'd have you guys try. And so have the addition of kind of a second variable in these, and not a big thing, just x's will go with x's and y's will go with y's. So this first one, we got 5 times 2 would be 10, and then times 7 would be 70. Double negatives, that's going to make it a positive. For the x's, I have 5, 4, and 3. So I'm just going to go 5 plus 4 is 9, plus 3 more would be 12. So x to the 12th. And then for the y's, we got 3, 4, and 8, so that'd be 12, 15 y's. Next one, double negative, so you can just think of that as a positive. 6 goes into 6 goes into 48 8 times. And then if we think 6x is up, 8x is down, and we cancel out 6 of them, I'll still have 2 left downstairs. And with the y's, 6 up and 5 down, so if I cancel 5 of them, I'll have 1 left upstairs. Again, you can do that with subtraction, but I don't know, canceling seems clear to me. Number 6, negative and negative will make a positive. 3 times 12 will give us 36. 3 and 7 gives us x to the 10th. And I'll just copy this part down. And then here, 9 into 36, so that'd be 4 times. I have 10 up and 13 down, so that would leave me 3 in the denominator. And then this one would be 5 times 6, so I'll be a negative 30. And then x to the 4th, x to the 2nd, so x to the 6th. And then a y and a y squared for y cubed. Downstairs, negative 3 times 2 will be negative 6, x6, x5, so that's going to be x11, y to the 7th, and y for y to the 8th. So there's the double negative again, so that's just going to be a positive. 6 goes into 30 5 times. And then I have 6x's up, 11 down. So if I cancel, that will leave me 5 downstairs. And 3 up and 8 down, so if I cancel out 3, that'll be 5y's also. So y to the 5th. Okay, so these next 3 are fairly challenging problems. So I'll point out the difference between 8 and 9. With 8, we have kind of 2 separate parentheses in the numerator and the denominator, and they're raised to different powers. So what we're going to have to do on that is powers first. We can't simplify this because this isn't 2, this isn't 4. This is really 2 cubed, which is 8. This is really 4 squared, which is 16. And so the numbers aren't what they look like. In that case, they actually do simplify down to a half both times. But if I change this to a fourth, then they wouldn't. So with the powers, with two separate powers, you gotta do powers first and then simplify. For this one, it's gonna be a little different. The whole fractions to this power. So that means I can simplify first, and it will be easier if I do so on this problem. So let me show you those two. So here I'm just gonna run this cube through the numerator. So 2 cubed is gonna give me 8. And the little interim step there is it's 3 times the little invisible 1, which is making the 2 cubed. So I'm just going to 8 right there. And then 3 times the -5 would give us -15. And 3 times the 6 would give us 18. Remember, when we're raising to a power, that's our ax to the y is the one where we multiply. So here, 4 is like a little 1 there, so that'd be 4 squared is 16. 2 times 3, that'll give me x to the 6th. And 2 times 12 will give me y to the 24th. So you can do this by the subtraction property, or with the negative exponents, if you want to think of it as either canceling or just combining, you need to rewrite them all with positive exponents. So I'm going to show it that way. First thing I'll do here, though, is 8 goes into 8 once, 8 goes into 16 twice. Or you can just think 8 goes into 16 twice, and the 2 is going to be where the big number is. So I'm going to rewrite this with that 2 there. X to the 6 is fine. This x to the -15 really should be in the denominator because it has that negative on it. So I'm going to write that down there. These two both have positive exponents, so I'm going to leave them where they are. And so now if I combine, I'm going to have the cat wandering through. So let me get the cat out of the way. Misha. Yes. All right. Here's Misha. Hi, Misha. Okay. Hopefully Misha will leave us alone. So we're going to have 2 downstairs. We're going to have 6 and 15, so that'd be 21 x's, so x to the 21. And then 18 up and 24 down, so that's going to leave me 6. So 18 minus 24, -6. So I'm going to write downstairs with the positive exponent. And since there's nothing left up here, it's like it's times a 1. And so we just need that little 1 placeholder. For number 9, this one's, I don't want to go 35 to the 3rd and figure out what that is. So instead what I'll do is 7 goes into 35 5 times, and that will make that a little bit simpler. This x to the 4th should really be downstairs. And so I'll go ahead and write it out. X squared, x to the 4th, y squared was cool, y to the 6th was cool, and with a cube. And then before I cube everything, I'm going to go ahead and combine and make that a little bit easier. So that'll be 5. 6y's up, 2y's down, so y to the 4th. And then 2 and 4 will give me x to the 6th downstairs. And then cubed. And then I just have to run my cube through. So that's going to look like 5 cubed, so that's our 1. So that'll be 125. 3 times 4 is going to give me y to the 12th. And then 3 times 6, x to the 18. So this one, I could simplify first. This has a negative exponent. It's about to mess up all the signs anyhow. So I think I'll just run it through and go x cubed, y -3, and then negative and negative, so +7 and -4. And then if I rewrite this with positive exponents, I just flip-flop these two, so the 4 comes up and then 3 goes down. And then simplifying, I have 3 x's up, 7 down, so that's going to be me x to the 4th, and then 3 down and 4 up, so I'd have, if I cancel, 1 left up top. So then these last 3 are the ones I'd have you guys try. So this one, 2 separate exponents, so I have to go ahead and do the cube and the square through first. So 3 to the 3rd, because it'd be 3 times 1, would be 27. And then x -15 and y to the 21. Downstairs I'd have 81, and 2 times -3 for -6, and then y to the 4th. And you know, I said 21, I think, and I wrote 7. Let me get that corrected, so that should be 21. Simplifying, so 27 goes into 81 3 times. So this will be a 1, and this will be a 3. And it might be that you do the 9s first and go, 9 goes into this 3, 9 goes into that 9, and then you see the 1/3 after that. I'll go ahead and rewrite this with positive exponents. So this will be 3x6 I'm bringing up, and the 15 I'm bringing down. And then I'll just do my little cancel thing. So let's see, we got a 3 downstairs, 6 up and 15 down, so that will leave me 9 in the denominator. 21y's up, 4 down, so that should leave me 17. So let's see, this one I can simplify a little bit first, so I'm going to do that. We're going to go 6 goes into 48, 8 goes into 48 6 times. So I have 6 there. And then these two are fine, the x5, y5. So I'm just going to leave those where they are. And then we flip-flop the negative ones. So the x to the negative 5 is coming down, y to the negative 2 is coming up, and still squared. So then I'll do some kind of collecting here, and I got 6, 5, and 2 on the y's, so that'll give me 7, and 5 and 5 on x's, which will give me 10. And then squared. So then lastly, 6 squared is 36. 2 times 7 is going to give me a 14. And then x to the 10th squared, careful not to do 100 there. It's going to go x to the 20th, because remember we're multiplying. This last one, so again, it's kind of the negative exponent thing, so I'll just go ahead and run that through. And that's just going to flip-flop all these signs. So this will be a positive 9 and a negative 6. And now I'm going to rewrite those as positives. So I'll bring this one up, and I'll bring this one down. And then canceling, let's see, 3 up, 6, 9 down, so that'll leave me x to the 6th. And then 6 up and 8 down will leave me a y squared. And then again, we need that one right there.